Hello and welcome to Module 6 of this webinar series on the Rural Access Index. These webinars are part of a TRL project with the aims of refining the methodology for RAI calculation, piloting application of the new methodology, and increasing awareness and use of the RAI in general. This presentation is part of a series. Each webinar in the series is a maximum of 10 to 15 minutes long, and some frequently asked questions are included at the end of each module. The webinars will cover the topics shown here. This sixth presentation covers the use of accessibility factors used to calculate RAI, with some examples from Malawi and Myanmar from 2019. We do recommend that you view these webinars in the sequence presented, but all the presentations will be made available separately and can be accessed as required. This webinar will cover RAI measurements and how accessibility factors can be used to assess the all-season status of a road network. We'll look at accessibility factors, why we need them, what they are, and who defines them. We'll also go into the details of the typical components of accessibility factors, definitions by zone and by district, and why ground truthing is necessary. So why do we need accessibility factors in the first place? The first paragraph shown here came from the Roberts report in 2006 and defines an all-season road as a road that is motorable all year round by the prevailing means of rural transport, which is often a pickup or a truck which does not have four-wheel drive. Predictable interruptions of short duration during inclement weather, e.g. heavy rainfall, are accepted, particularly on low-volume roads. Now, in the supplemental guidelines in 2019, we clarified that a road that is impassable for more than a total of 7 days over the course of a year is not regarded as all-season. These days do not need to be consecutive. However, few road agencies in the world collect data on the number of days that an individual road is impassable. So, in the absence of such data, the supplemental guidelines also developed the concept of accessibility factors. Now, what are accessibility factors? Accessibility factors provide an alternative means to estimate the all-season status of road networks if road condition data is not available. They basically represent the likelihood of a group or network of roads being all-season, and so are closely aligned with the original 2006 study's allowance for roads being temporarily unavailable during inclement weather. Accessibility factors can be based on variables that determine the all-season nature of a road, such as surface type, climate, and terrain. This can be defined in a workshop with local engineers and/or transport operators without the need for onerous extra data collection. Accessibility factors are combinations of factors that are likely to cause a road to become impassable for more than 7 days per year. Typical examples are surface type, so many rural road networks include a high percentage of unpaved roads, which of course are more likely to be impassable than paved roads in general. Climate is another big factor where a significant wet season or intense precipitation can cause flooding and/or landslides, leading to road closures for long periods of time. And finally, terrain is important because roads through hilly or mountainous terrain are at higher risk of being blocked by landslides. Roads through low-lying coastal terrain are at higher risk of erosion, water damage, or flooding due to rising sea levels. So who should define the accessibility factors for a given RAI calculation exercise? Firstly, any stakeholders involved in the calculation of the RAI can be involved in defining the accessibility factors. These stakeholders should include all roads agencies in the country, the National Statistical Office or offices, and any others involved in the definition of RAI, for example, rural development agencies. Liaison with local staff who are familiar with the rural road networks is essential. The best way to gain agreement on accessibility factors is to discuss them in a workshop setting with representatives from each of the RAI stakeholders, including experienced district engineers. We'll now look at some typical components of accessibility factors. The surface type of a road is important in defining accessibility factors because unpaved roads are more vulnerable to damage and therefore being unavailable than paved roads. Most roads databases will include surface type information, including a breakdown of paved and unpaved roads. If there is mapping of the geometry of the road network available, then it's usually possible to produce surface type mapping fairly easily using standard GIS tools. Other information such as road classification and maintenance regimes may also be relevant. As we discussed back in webinar number 4 on data sources, some roads will be part of a classified national network, some will be part of a local roads network, and still others will be unclassified. These definitions will vary between countries, but there are often at least 3 different types of road classification and usually at least 2 different types of road agency. Now, there's often very little difference to be observed on the ground between roads with different classifications, as can be seen in these photos from Malawi taken in 2019. Note that even the unclassified network often provides an important rural access function. Climate zones are also a useful component of accessibility factors. There are usually several sources of climate and weather data within a country. Whoever calculates RAI should consult the National Meteorology Department for details of weather data, but online sources such as the World Map of Major Köppen classification types as shown on this slide can be a useful resource for general weather data. Köppen also provide detailed maps for each country. Country information and maps can be used to determine significantly different zones of climate. So this usually involves identifying climate zones in terms of the risk to deterioration and availability of roads, and therefore the likelihood that roads will be all season or not. It's recommended that the country is divided into 2 categories, high risk and low risk. For example, in Malawi, districts in the extreme south are at high risk from very intense rainfall events in the monsoon season. The rest of the country, however, is generally dry and is therefore at low risk. A country should be divided into areas that indicate the risk to road deterioration as a result of terrain. It's recommended that countries are divided into zones of high and low risk, and this can be done on the basis of administrative boundaries. Although digital terrain models are freely available for the entire world, a simple classification of districts such as high and low terrain risk is sufficient to help define accessibility factors. Areas that include high risk would typically be hilly or mountainous terrain with unstable or slippery materials and medium to high risk of landslides. Areas of high risk could also include difficult terrain such as low-lying areas close to the sea, lakes or rivers with a high risk of flooding and/or erosion. But this would only be applied if it affects a large area such as a district or a county. Low-risk terrain would include flat or rolling terrain not affected by floods, with a small risk of landslides, and road materials with medium to low plasticity. So we'll now look at how to combine the different components of accessibility factors which we've just seen. These diagrams show how the climate risk and the terrain risk can be combined to produce a map of a country, in this case Myanmar, with accessibility factor zones. These zones can then inform the person calculating RAI which administrative areas are at high or low risk. Each zone can be assigned an accessibility factor based on the risk of roads not being all season. An example of how these can be used to define accessibility factors is shown in the next slide. So here, using risk zones as shown on the previous slide, accessibility factors should be defined specifically by road surface type. The tables shown here are just an example of how to do that. Engineers can agree at a high level the percentage of paved and unpaved roads that are deemed to be impassable per zone. Now this is shown as a factor, So for example, if all roads are deemed to be all season, the factor will be 1, and if 90% of the roads are all season, the factor will be 0.9. This can be corroborated by looking at individual districts as described in the next slide. If the mapping is complete and if there is in-country GIS capability, then the high-level zone factors can be refined based on identification on a map and measurement of lengths of roads that are all season against those which are not all season. Such an exercise was carried out in Malawi in the space of 2 weeks. The Road Management Division in Malawi Roads Authority simply emailed their district engineers and asked them to mark all season and not all season roads on a PDF map to identify accessibility factors at a district level. This module has been the 6th in the series of 7 modules on the RAI. All other modules are available on the ReCAP YouTube channel and on the World Bank Data Catalog website. These are the key references for the information given in this presentation, and please refer to these as necessary. Here we're going to go over some frequently asked questions relating to accessibility factors. First question, an all-season road can be closed for up to 7 days per year and still be all season, so is that 7 consecutive days or a total of 7 days within the year? So this is a total of 7 days over the course of a year, not necessarily consecutive days. So for example, a road could be closed several times for short periods, but as long as the total of these closures does not exceed 7 days in a year, it's still considered to be an all-season road. Second question, how do we agree on the accessibility factors? So we've given 2 examples in the presentation, by zone or by district. It's up to each country to define something practical and workable for them, and which everybody can agree to. It's up to the country to agree among the various stakeholders what the climatic zone should be, whether there are differences or significant differences in impassability in different terrain areas, and so on. The actual numbers used for the factors should be defined based on local knowledge and should be sense checked by ground truthing as we described in the presentation. Third question is, how would maintenance of a network affect the accessibility factors? So the accessibility factors are based on the current status of the roads, which by default includes how well they have been maintained. But accessibility factors can be reviewed on the basis of new maintenance policies or practices if all stakeholders agree that they have made a significant difference to the all-season status of the network. Fourth and final question is, how do I select areas for ground truthing? Well, firstly, a broad assessment should be made of the high and low risk areas within the country based on climate and terrain as described earlier. Then advice should be taken from local engineers to select districts or countries that would be representative of each area, and the ground truthing should be carried out in those areas. If there's potential variation within an area, then 2 or 3 districts should be ground truthed and the results averaged across them to produce the relevant accessibility factor. So that's the end of this webinar. Thanks for watching, and we hope you found it useful. You can find more information on the ReCAP website and in the references provided earlier in this presentation. You can also access the other modules in this series via the ReCAP YouTube channel and on the World Bank Data Catalog website.